It's freezing. So bad. All right, control room. Let's see. I have a paper.
That's all I really want. There we go. Jeez. Still up there. Safe.
All right. Well, I have to use special blue color. I'll use just white. All right. So let's see. Are you working on your homework assignments? Is it working for you? Getting it right?
Not good.
The third trial, the second trial,
Started it.
or the first? Yeah, okay. Well, keep practicing. Now, and I think I didn't say anything about exam last time. I didn't say anything. Yeah, I'll leave you. So, okay, at least I said that. All right. Okay. So, do you have any questions from the homework? Something maybe that you're still not sure how to do? Yes, no? So, I'm going to change a little bit some things that we have. I plan on the syllabus, so I'm just going to finish today the last section. So after this, there will be no new lectures. Okay? So, I'm not teaching section 6.4. I'm going to section 6.5. It's a very easy section, not a complicated section, and as kind of conclusion of this 6.5 section, you just have to remember the formula, and that's it. Okay. Now, 6.5 is not on this exam. It will be on the final. Just one call. Okay, but I just want to finish. So today we're going to finish with the whole thing. There will be nothing added. So we'll be done with Calc 1. Okay, so you've seen it. Or no, it's a little bit different. Like some of you, maybe specifically high school students, if you're talking about like AP exams, overall this class covers a little bit less than AP exam. Okay, because it's not designed AP. So let's just keep going, and then we'll see how much time we'll spend working on this section. And if we have extra time, then I'll still ask questions. Or maybe I can do one or two extra problems, and then we'll finish. So tomorrow, we're starting the review for the exam, and we'll see how that goes, okay? So I'll tell you what you have on the exam, that you know exactly, that you don't have to study extras. I'll show you the problems that kind of similar that you will have on the exam. And then on Monday, Tuesday, we'll take the exam. But also, I probably will start doing the final review. So I don't know how many days we need for the test, exam 4 review. But if we have extra, then we definitely will spend more time reviewing for the final So for the final, as I said before, we're going to use regular exams. So make sure you find exam 1, 2, and 3. And then when I grade your exam 4, I'll give it back to you. And if you have questions, we'll talk about that. So going to section 6.5. So the topic, we call it average value of the function. So don't forget, well, basically chapter 6 is how we can use integrals. Kind of a little bit limited way. We're not talking about the full potential of integral that basically goes into specific areas, engineering, computer science, maybe even medicine or biology, chemistry. Here we're just basically looking at the volumes, let's say, and one of the usage of the integral is to calculate the average value of the function. Now, overall, we know how to find average, right? If I give you, for example, 20 numbers, how do you find average?
Add up, divided by 20.
Right, so you add all those numbers together and divide by how many we have. So that's the normal process. Now, normally, students will ask me, like, what is the average on the exam? And normally I'm going to say, average will not reflect the true picture of the exam. You understand that? Because, for example, if somebody scores 95%, let's say 2 people. One scores 95, the other one scores 30%. When I average, it will not reflect the picture of the success or failure, right? So average is not the best tool to describe the process, okay? In real life, let's say. But overall, as you mentioned this, if we're looking, for example, some average value, normally we'll just add numbers, right? Whatever, how many we have them. Let's put a lot of them n numbers, and then you divide by n. Now, where we have the difficulty with this concept, when we talk about average value of the function. Now, when I say average value of the function, is it x value or y value? What do you think? When we say average value of the function. So, I added word average, right? But overall, I'm talking about the value of the function, right? The value of the function comes from y-axis. So it's y value, right? So think about this. Let's put a little sketch over here. So now, if I say just like, okay, here's the function, let's find the average value of this function, it's impossible. Why? Because your function may go forever up if you go to the right. You know what I'm saying, right? Just going up forever, infinity. Same thing maybe going up forever if you go to the left. So we cannot find average value if our function doesn't have that interval where we're looking for this average. So again, if you're trying to find average of value of the function, we always have to have the interval. So we have interval from A, for example, to B. And let's say I have something like this as my function. So this will be my y equals f of x. So if I follow the same idea as I have over here, if you look like how many numbers we have, right, adding them together, dividing, I cannot do this. Because look, if I want to know average value of the function, then I need to know every value of this function on this interval. You understand that? When I say every, it's kind of dangerous for the function. Because how many numbers do I have to substitute into the function? Infinite, right? Because overall in algebra we have theorem which says this. If you have two numbers, there's always another number where? Between those two. Even if you use microscope, you put two irrational numbers next to each other, there's always one is sitting there in between. You understand that when I say irrational? That's those what? Square roots, or pi, right, or e, those are rational numbers. So it's impossible. I cannot just say, okay, what if I put a number over here? Well, so what? Well, I get one value, right? But remember I said if you want to calculate average value of the function, you need to have every value of this function on this interval. Do you understand what I'm saying? And you cannot do this. So somehow we need to develop the formula that we can calculate this. And we'll start with theory, and then we'll go into a little bit more practical concept here. By just using algebra, it's impossible to find average value of the function. So, how do we do this? Well, we kind of follow the same concept like we had over here. Okay, except I'm not going to say y sub 1. I'm going to say, okay, I'm going to have my function, and then I will substitute values. Now keep in mind when I'm writing this, what I put over here, I'm considering what? Every value that I have. You see that? It looks short, nice, and sweet, but basically what I'm saying, every y value of every point on this curve. That's what I'm looking at. And then obvious, depends how many I have of them, I will divide by n. So one more time. It looks almost the same as this one, but here I'm saying what? Every y value on this curve. And we have many of those. Okay? So technically what I'm saying that n here is what? Very large number, right? You understand what I'm saying? Or I can say what? Infinity later on in the moment. So this is what we have. So let's continue with this, and let's kind of approach this from calculus, or even a little bit maybe pre-calculus point of view. Do you remember the short way of writing these values on the top? How can you present this as a short way of writing? Through what? Just the toppings. Now it's long, right? F of something plus f of something plus f of something plus, right? How can you make this small? So you use sigma notation, that's right. So what's going to happen here, you will have a sum. I equals 1 to n f of x sub I. So that's how we show this through sigma as a sum and over n. So you see I'm already involving this sigma idea, okay? The next problem that I have that I really don't know what n is, okay? Overall, I don't know what n is. So I have to kind of think how to get rid of this n. And this n is easy to get rid of it as the expression through our delta x. Okay, do you remember what delta x was as the formula? What? So we have what? If I move it down, right, we have what? A and B, right? Right? So what is delta x? Remember the formula? Just give me the formula. B, right? Then what? Minus A and over n, right? And from here, I will find what n is. Because remember, I want to get rid of it because I don't know what n is. So, what do we get here? What is n? B minus A, right? Divided by what?
Delta x.
And so what we do now, we take this expression and substitute for n, okay? As kind of the process goes. So I equals 1 to n, f of x sub I over b minus a over delta x. Well, now I have a complex fraction, right? So I have to fix it, make it normal expression. And when I do this, let me move this away. When I do this, this delta x will move up, right? Because you're multiplying by reciprocal. So what's going to happen, you'll have something like this. Delta x, sum, I equals 1 to n, f of x sub I, over b minus a. But if you remember from previous sections, this delta x doesn't have to be in front. It's nice. But I have a goal. I can see it already what's going to happen next. So what I'm going to do, I'm going to take this delta x and put it inside of the sum. Which is kind of, I mean, algebraically doesn't do much because it's just a look. But now, as a theory, it's very beneficial to have it inside. So what I have something like this. Now, what's on the top right now? Remember the name of this? Riemann sum, right? It's a Riemann sum. So you have Riemann sum divided by b minus a, right? But remember what we just said before. Our n is what? Too large, which is what? Infinity, right? So what I can do right now, instead of having Riemann sum over here, I will say limit of the Riemann sum. When n is approaching to infinity, I equals 1 to n, f of x sub I, delta x, and over b minus a. But what is the limit of the Riemann sum? It's the integral, right? It's the integral. So we have integral from a to b, f of x dx, over b minus a. And that's the formula for the average value of the function. So I'm going to put it right here, f average. And in the book, they put it this way, but this is still good. I personally kind of like this a little more, but they put this like 1 over b minus a times by integral from a to b, f of x dx. So remember I said at the beginning, to make this b better here, okay, so integral from a to b. I told you at the beginning, the only thing what you have to remember is this one. And it's very easy to remember, because you have integral, and then you just multiplying by 1 over b minus a, right? And what is b minus a? It's the length of the integral. So that's it, okay? It took a little bit of time just to develop, but overall it's a very simple formula. So the biggest mistake what I see on the final exam, again speaking about final exam, the students remember that there is the integral when I have to calculate the average. But they're forgetting this 1 over b minus a. So don't forget this piece, but everything else is just the integral. So we're going to do 2 problems with this concept, and you will see it's a very simple problem to do, but then what kind of function we'll get, that will determine the difficulty of the integral. Okay, so let's take a look at example number 1. So the function that I have is f of x, or they can say y equals, doesn't make a difference, 1 plus x squared, and we have to find average value of this function on interval -1 and 2. So we're looking for average value. Well, I mean, I have everything what I need. I don't need anything else in order to find average value. So 1 over, right, and this formula says b minus a. So 1 over what? 3, right? So 2 minus -1, right? So b minus a, just in case you forgot, this is your b, this is your a. And then times by integral from -1 to 2, we have this interval right here from 1 to 2, and then my function, 1 plus x squared dx. So we do have very simple integral. It's 1 over 3. We can go straight to antiderivative, right? It's just 1 plus x squared. So what is antiderivative of 1? X, right? And this will be what? X cubed over 3. And from -1 to 2. Now, please do not forget that you have lower limits as -1 and 2, because you know when after the volume problems, we always think it's like maybe 0, 1. Kind of we forget that it's different numbers. So when we substitute, I have 1 over 3. I'm going to keep it completely outside. So I have here 2 plus 2 cubed over 3 minus -1 minus 1 over 3. So this is what I get when I substitute. And from here, it's up to you. If you want to go by hand, kind of go slow and get the numbers, that's okay. But overall, you'll get 1 over 3 times by 6. So all of this is 6. Okay, it's easy to calculate simple fractions. And we'll get what? 2. So the average value of this function on this interval is 2. Now what is 2 overall? That's the y value, right? So we can consider this as what? Horizontal line that can show us where the average value is. So let's take a look at the graph and see what else we can get out of it. So if we look at the picture, so I guess it's going to be small. I don't know why I did it this way. Fine. So let's say we have -1. It's right here. We have 1 and we have 2. So if I substitute -1 into my function, I will get 2. Where will be the vertex of this function? At what? Now, it says what? 1 plus x squared, right? Do you know what that is? How do you graph it? It's just 1 unit up, right? So the vertex will be at what? 0, 1. And then if I go with 2, I need to put 5. So 1, 2, 3, 4, and 5. So this is how my function looks like. Okay, just a parabola. And average value, which is what? 2 right here, right? Will be over here. So this is my average value. Alright? So we found the average value. And so we don't have to find every single number, right, that we can get just using the integral. Okay. But the next question right here is, if you just get rid of this 1 over 3, so if I take just the function and I have just integral, that integral will represent area under the curve. Yes, no? Remember, get rid of this 1 over 3. So if you take away from the formula this piece, you just have integral, nothing else, right? And it's what? Again, area under the curve, right? You have area under the curve. So if I put this -1, and I'll put 2, and 1, 2, 3, 4, 5, let's say, and I will get the picture. So integral itself will give me this area. Do you understand? Okay? But then, what else do you think has exactly the same area if you involve the average value as a picture? If you compare these two, can you guess what else has the same area? Because my area here is 6, right? Remember? This piece over here, because this was 1 over 3, right? And integral itself gave me what? 6, right? So this area over here is 6. But what else do you think we have, or we can create, that has exactly the same area if you look at this picture? It is, right. It's the rectangle. So if you look carefully at this picture, and I'll put it over here. So this is -1, and this is 1 and 2. And remember, average value is what? 2. So here what we have, this rectangle over here also has area, which is 6. 2 by 1. Great. Can you see that? So what I'm saying, like, this is just kind of, this is how you look, and this is how you observe extra pieces. Overall, this is not on the exam, but I still want you to see. So what we can get out of this, if I know the average value of the function on the interval, then I can easily find the area under the curve without integral. Do you see what I'm saying? Like in order for me to find area over here, I need to use integral, right? Area under the curve. But if I know average value and I know the interval, I can just use rectangle and get exactly the same one. Exactly the same area. So instead of going through the process finding the integral, if I know average value, I can just find the area. And it will be, these will be exactly the same. So this is just kind of observing, looking at the pictures and trying to understand what we have. So in addition to this question, like what is the average value, they may ask you to tell where you have that average value. Now when we say where, if you have a picture, it's easy to see because average value will be at what? -1 and what? 1, right? Yourself. But not every time we'll have nice and beautiful picture like this that you can just look and see. So we have to use algebra. How can algebraically you can prove that average value will be at -1 and positive? What do you have to do? Right, you take the function and set it equal to 2, right? Y equals to 2, because what? It's y equals 2, right? It's your value of the function. And in the book, they actually call this not x, but call it c. Remember a mean value theorem, where they say find c? So we will change this to c squared equals 2. So c squared equals 1, so c will be plus or minus 1. So when x, that's easy even to see, but or c is positive or -1, that's where function will get the average value. You see what I'm saying? So that's this. So this one has 2 questions. One, find the average, and then the question is where you will get this average. And this average will get, again, if I put picture back, we'll have a -1 and +1. That's where we'll have this 2. Just a second. Now, quick question. What if you cannot solve it, this equation kind of nice and easy? Can you use calculator to determine those axes? Can you do it? How would you do it? So how would you use your calculator to get these axes? Knowing the function and knowing what? The average value. How can you use your calculator to get those? Right. So, I mean, I'm going to do this just for to refresh this, but we can actually go to the calculator. Now, if they're saying round to something, then calculator will be a good tool to use. Now, if they're saying exact, then we have to suffer and use whatever formula or whatever you have to use. But overall, you know, when we say y equals 2, and then we say 1 plus x squared, so these 2 we have, and when we graph, this is what we have. Okay, and then what do we do? And you can zoom in, it's not a big deal here. Let's see if we can get a nice picture. Alright, so remember you go to second, trace, and you calculate 5. Intersection, right? Not 0. And then it says, okay, this is the first curve, that's fine. This is the second, fine, guess. I'm going to go a little bit to the left. And then I hit enter, and I'll get my -1. So do you understand, right? So now I'm saying this because sometimes when I get nice and beautiful function, okay, maybe we have something more complicated than just 1 plus x squared. Then the intersection or points will not be just natural numbers or maybe integers. It may be irrational numbers. And if it says to round, it will be great. So let's just take a look again at a similar problem. We're going to look at example 2. And we'll put a little bit more complicated function. So let's say my function is f of x. Let me switch this, but we can see it. f of x equals 1 over x square root of natural log of x. And we're trying to find the average value on this interval, e and e to the fourth. So if we go to the formula, what do I get on the bottom? So e to the fourth minus e. And I asked in my previous classes, is it e cubed? E to the fourth minus e. Is it e cubed? What do you think?
No.
No.
The answer is no. Absolutely right. And one of the students says, if this will be the case, then we have no polynomials. You know what that means, right? Like if you have x squared minus x, right? Well, that would be just x, right? So, but that's the case. Okay, so good. Keep in mind it's not e cubed, right? Then we have integral from e to e to the fourth, and then just our function. So this function is more complicated comparing with the previous example, and now I have to find a way to find this integral, right? Antiderivative. Right, so if I start kind of looking at this function, right, inside of the integral, there's nothing that takes me exactly to the table, right? Like, I have nothing like this on the table. So I have to think about other ways of doing it, and substitution will be used here. So if you go with the substitution, u will be natural log of x. And again, if you kind of forgot why we use substitution, mainly we use for the compositions, right? And here you do have a composition. It's your square root of natural log of x. It's inside. But don't forget, as I told you before, when we had section 5.5, you try it. If it doesn't work, quit. Use another substitution. So du over dx will be 1 over x. So then dx, remember we need dx to put something instead of it. What will be dx? But do math right here. X du, that's right. Not the division this time. Normally it's like divide, 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 and we get this idea that we always divide. Not the case here. We have to get to this. Another thing is, remember, this is what? Definite integral. So, excuse me, what else do we have to do? It's a definite integral. We have to change up our local limits, okay? And this will be actually good for us this time, because if x is e, then what is u? So what do? We take e right here, right? Natural log of e, which is just 1. You see how nice this is. And if x is e to the fourth, then u, right, again, you put right here, will be just 1, 4. So nice upper and lower limits right now. So now we're going to substitute. So I still have this 1 over e to the fourth minus e. Now integral will be from 1 to 4. And now I have 1 over x square root of u, and then I have x du. Taking all the information from here. So x's will be canceled. And as the result, I have 1 over square root of u, and you know what to do with that one, right? We have to what? Change this as u to negative 1 over 2, right? And use the rule from the power function. So 1 over e to the fourth minus e. And here we'll have integral from 1 to 4, and I have u to negative 1 over 2 du. You have to be comfortable with easy stuff, okay? This is easy stuff right now. It's just a power function. I do have a square root, but again, don't create something strange here. That's all we have. So, what will be the antiderivative of u to negative 1 over 2? So that's right. So we're going to add 1, right? So you get 1 over 2. And you divide by 1 over 2, so 2 will go up. So we'll have 2u to 1 over 2. That's the antiderivative. And this has to go from 1 to 4. So probably will be easier for us if we kind of put this 2 above the e minus all of this piece. So we'll have 2 e to the 4th minus e. And then everything else I'm going to do inside. And we have 4 to 1 over 2 minus 1 to 1 over 2. So 4 to 1 over 2 is what? 2. And 1 to 1 over 2 is 1. So 2 minus 1 is just what? 1. So the final answer will be e to the 4th minus, and that's the average value. Again, don't rush to use your calculator getting decimals. We're looking for the exact average value. Okay, you understand? So if I will say again, like for example, I'm going to, overall the question, what I'm going to ask you right now is not part of the problem, but what if I'm going to say, okay, tell me for what x this function will get this average value, then what do you have to do? Then you have to write what? 1 over, right? And if you put c, that's fine, right? Or x, square root of natural log of c equals what? 2 over, right? That what? E to the 4th minus c. And you have to solve this equation if you want to know for what x you will get this average value. Now, the question is, can we do it, right? What do you think? Can we do this algebraic? It will be difficult, very difficult. So that's why it's a good thing to just go back again. Let's go back quickly to the calculator, put this in, and we'll get those numbers. So I'm going to go back to the function, delete this. So what are we going to put? Function maybe, and again I have to put x. So 1 over, and again my calculator doesn't do the fraction like maybe some of you newer versions. So you need to put parentheses around the denominator, okay? Don't forget them. So you have x, then you have square root of natural log. Okay, what's my natural log? Somewhere over here, okay. Natural log of x. Make sure you have the right number of parentheses. So, do we have the right one, or I'm still missing one?
Missing one.
Missing one, okay, so I'm going to put one more. So that will give you the function. And here, we'll do the same thing. We're going to put 2 divided, parentheses, and e, you have e, it's above the natural log, e to the 4th, minus just e, so you can find, well, you can do this one too, but with 1 if you want. So this is what we have. All right, so it brings a little trouble just to put it in, but it is better instead of solving this. So now I'm going to go zoom 6 because I have no idea how a graph is going to look like. All right, so what I don't see here, looks like I have a little piece of curve, right? But what I do not see, probably the line, right? So I have to zoom in and see if I can get any line out of it.
I've seen it a bit more.
Huh?
The line is at like 0.003 something.
Right, so that's the problem for us, right? So we may have to change the scale here in order to see where the line will intersect at. And this can be very far, far away. Okay, because the line is very small. So you see we have a little problem here. And how do we change the window? Because I'm kind of playing with this, I want to see this. So let's talk about changing the window. X. What do I need for X? Maybe from, let's say, -1 to how far? I'm guessing how far. 20? 50? Because I don't know. So, I don't know, let's put 30 kind of. What about y? Minimum -1 will work, right? And maximum maybe, how far do I want to go? Maybe only 2 units, right? Maybe 2. So let's see what we get here. Okay, and I still do not see the line. I still don't see the line. So going back to window, and this one maybe I'll put, what should I put here? You said point what?
0.038 something.
0.3. So I'm going to put 0.6. Okay, so that didn't give me much. What did I put? Forgot the negative sign or something? Oh, there's a line. Okay, barely you can see. Let's go back to the window and I see what else. Okay, so minimum is 1. That's too big, right? So I'll put like -0.01, or I can actually use this as y-axis. So something like this. And we have the line. All right, so I see where it's intersecting. Well, here's the thing. I know you're saying, like, well, it's suffering over here. I'm guessing, I'm trying. But overall, look, if I have to solve this, I cannot do it. So I'm playing with the calculator trying to see. So let's just find this intersection here. So second, trace, we get intersection number 5. So asking about the first curve, that's my yes. Then we're getting the second curve, it says guess. And what do we get? Right there. So I was a little bit off, right? It's just 15. So C here will be approximately, let's go only 1 decimal place. So we get 15.6. So that's where you will get your average function. Do you understand? All right. So that's with this one. And let's just kind of, one problem, we have 5 minutes. Let's kind of look at one problem from your, I don't know if I can say homework assignment, but I think it's, I'm not going to tell you actually what section this is, because I want you to decide if we go with washer or the shell, okay? So we have to make a decision here. So for example, I have function y equals cosine of x. Other function I have y equals sine of x. And I'm looking at this on the interval from 0 to pi over 4. And I have to rotate this about y equals -1. All right, so this is what we have. So if you sketch the graph, let's put this right here. If you sketch the graph, now we know that cosine and sine will intersect each other at pi. I'm going to do zoom 6 again and get rid of the functions. Waiting for the calculator to finish calculating this. So we're going to clear this and clear this. So what do I have? I have cosine of x. Now one more time, I want to remind you, make sure your function calculator is in radians. So this is what I have when I graph this. So that was cosine. Now sine is coming in. It's too small. I'm going to zoom in. And this will be enough. We'll see. Okay, so that's enough. And pi over 4 will be right here where graphs intersecting each other, okay? So I will have something, let's put pi over 4 here. Gonna make small graph. So cosine will go like this, and sine will go like this. So you get this little piece. And what else is missing, because I'm looking at a different piece of paper, probably I should have something like this, like x equals 0. But I actually set from 0 to pi over 4, right? So we really don't need this. So this is the little piece that I have over here. That's the little piece. Let me get rid of my calculator, okay? So this little piece. And this little piece has to be rotated about y equals -1. Do you understand? Y equals -1. All right. So when you rotate this, probably will be somewhere over here. And I'm really trying to express this the right way. Something like this. So the next question, let's talk about the methods. So we have washer, we have shell. So let's go with this before we do anything. So if I say, for example, washer, dx or dy? Dx, right? Why? Because axis of rotation is parallel to what? X-axis. Good. So then if I go with the shell, then I get what? Dy. So here's my question. Now, since we know dx, dy, what method will you choose? Washer? Or does it make a difference? Does it make any difference? We can use either one. So what do you think is going to happen if you go with the shell method? What do you have to do?
Convert it into y.
So it says what? Dy, right? So that means every function that we have right here, you have to solve for x. And what that does? That brings the inverse, right? So this will be what? X equals inverse what? Cosine of y. And this will be x equals inverse what? Sine of y. Do you think that will be easy? Yeah. So you see I'm stuck. I have no choice but to go with what? Well, you can check that. It's not easy. But there, you will have it. I think in the back of the book. But we're going with this. So this is not a good idea, okay? Not a good idea. So, again, if you go with the washer, you have to do a cross section, right? You have to do a cross section. Now remember, I just put one line kind of, but overall it's what? It's the washer, right? Overall, it's the washer. So I need my radius larger, and that means what? The distance from here, from axis of rotation to the original piece, right? So I need this distance from here to right here. What do we get? What is distance from here? And this is -1. From here to right here. So 1 plus cosine of x. That's good. 1 plus cosine of x. We're almost done. I'm not going to solve it, we'll set up. So distance from here to here, this is, at the top is 1 cosine of x, and this will be 1 plus cosine of x, and radius small will be what? From here to here, right? So 1 plus sine.
On Wednesday, November 28th
Okay,
at
so,
7 p.m.
so then a of x is what?
Science class. So for all the students that are in science class, our color party is today after school in Mr. Barnes' room.
Right.
We'll be eating colorful foods and tie-dyeing our club t-shirts.
Next.
If you bought a shirt but won't be able to come to the activity,
What
you
do we
need to
get?
contact Mrs. Larson
Yes, that's
ASAP.
right. Pi.
Spartan Fueling Station. Don't forget to fuel your body for after-school activities. The Spartan Fueling Station is open Tuesdays and Thursdays after school for healthy snacks.
Just integral, and we will be done.
And here's Mr. Ponto.
So, integral.
Teachers, please be aware that those of you who had trimester classes, the grades have rolled. So if you are changing grades at this point in time, you need to let one of the counselors know with the percentage so that we can adjust the grades accordingly. Thank you, and here's Kate.
Sine of x.
That's all the announcements we have for today, Minico. Stay Spartan strong and remember, champions remain here.
This will be deemed. And how would you solve this? The rest. How would you do the rest? Right, you have to open parentheses, okay, you have to open parentheses. You have to combine like terms. One thing what I saw students did, and I think you did this, right? You asked me the question, right? I realized one little thing here, and I really want to show you this. Okay, right, and I just looked over here, and I just realized that that's what we have, because I gave you a more complicated way of doing it. Right. So, well, I guess I just want to show you, because if some of you are still working on this. So we get 1, then we get plus what? 2 cosine of x plus cosine of square of x, that's this one, minus, and I will square and change the signs. So minus 1, minus 2 sine of x, and then we'll get minus what? Sine squared of x. And this is whole thing dx, right? So, where the question was, okay, so this will be gone, okay, so finishing, almost. And the question here was, what do we do with cosine squared of x and minus sine squared of x? Because 2 cosine of x minus 2 sine of x, easy to work with, right, as the derivatives. But here we have plus cosine squared of x minus sine squared of x. And I said in class last time when you left, I said, well, put this one as 1 minus cosine of 2x over 2. But I didn't see, and I just saw this right now, that this is the identity right here. This is the identity. And what is this as identity? It's, anybody?
1.
No, plus. If you have plus, that's what you get 1. But this one is actually cosine of 2x. This whole thing over here is cosine of 2x. And then you just make easy substitution. 2x is u, and then do the rest. Okay? So that's the only thing what I wanted to add. All right. Well, thank you guys. So we finished with the whole thing. So tomorrow we'll start reviewing. We'll go over similar problems that you will have on the exam, and also keep working, bring the questions, maybe even those past homework assignments with close. If you still have questions, if you're not sure how to do it, what happened. So we'll spend some more.
Turn the lights on.